Hello there, and welcome to Midnight Geography. Tonight, we'll drift into the ancient spine of North America. The Rocky Mountains are time made visible in stone, a testament to Earth's infinite patience, where ocean floors became sky-touching peaks through unimaginable forces. They are both barrier and bridge, dividing waters that flow to different seas while connecting ecosystems from New Mexico's deserts to Alberta's glaciers. If you enjoy these peaceful geographical explorations, consider liking and subscribing. It helps other curious minds find their way here too. But for now, let's begin. The Rocky Mountains stretch themselves across the continent like a sleeping giant, running 3,000 miles from British Columbia's Liard River all the way down to New Mexico's Sangre de Cristo Range. This distance surpasses the journey from London to Cairo, yet it represents a single, continuous mountain system. When you stand anywhere along this chain, you're touching a thread that connects the subarctic wilderness of northern Canada to the high deserts of the American Southwest. The mountains change their character as they flow southward, from the glacier-carved valleys of the north through the volcanic peaks of Wyoming, past Colorado's famous 14ers, and finally into the red rock country where the Rockies begin their transition into desert. This continuity creates corridors for wildlife, channels for weather, and pathways for the human imagination that have shaped the continent's history for thousands of years. Mount Elbert rises above Colorado as the highest peak in the entire Rocky Mountain chain, reaching 14,440 feet into the thin air. Yet, this monarch of mountains holds a secret in its limestone bones. It was once the floor of a warm, shallow sea. 300 million years ago, where eagles now soar through alpine air, strange armored fish swam through tropical waters. The limestone that forms much of Elbert's mass is built from countless tiny shells and coral skeletons compressed over eons into solid rock. Then, in a demonstration of Earth's ability to completely reimagine itself, tectonic forces lifted this ancient seafloor nearly 3 miles into the sky. When climbers reach Elbert's summit, gasping in air that contains half the oxygen found at sea level, they're standing on what was once mud at the bottom of an ocean, transformed and elevated into Colorado's ceiling. Along the rocky spine of the continent runs an invisible line that determines the fate of every raindrop, the Great Divide, also known as the Continental Divide. This geographical feature follows the highest ridges of the Rockies, creating a boundary that seems almost magical in its simplicity. A single drop of water falling on the western side of this line will eventually find its way to the Pacific Ocean. The same drop, landing just inches to the east, begins a journey toward the Atlantic. At some points along the divide, you can literally stand with one foot on each side, straddling the destiny of precipitation. The divide doesn't just separate waters, it creates entirely different worlds on either side. The western slopes often receive abundant moisture from Pacific storms, creating lush forests, while the eastern slopes lie in rain shadow, supporting grasslands and different ecosystems entirely. This single line, invisible yet absolute, has been directing the flow of water for millions of years. Deep beneath Wyoming's Yellowstone National Park, a massive chamber of molten rock simmers and churns, occasionally reminding the surface world of its presence through geysers and hot springs. The Yellowstone caldera, formed by a catastrophic eruption 640,000 years ago, created a depression 34 miles wide, large enough to hold a major city. The eruption that formed this caldera ejected so much material that ash fell as far away as Mississippi. Today, the caldera breathes slowly, rising and falling by inches over the years as magma moves beneath. The ground here is merely a thin crust over immense geological forces that have erupted catastrophically 3 times in the last 2 million years. Between these apocalyptic events, the caldera sleeps fitfully, its dreams manifesting as the countless thermal features that make Yellowstone unique on Earth. The next eruption could come tomorrow or in 100,000 years. The mountain keeps its own counsel about time. Perched at 10,152 feet above sea level, the town of Leadville, Colorado, holds a remarkable distinction. It's the highest incorporated city in North America. At this elevation, water boils at a lower temperature. Visitors often struggle with altitude sickness, and the growing season lasts barely 2 months. Yet people have lived here continuously since the silver boom of the late 1800s, adapting to an environment where the air contains 30% less oxygen than at sea level. The town sits in a broad valley surrounded by some of Colorado's highest peaks, including Mount Elbert and Mount Massive. On winter nights, temperatures can plunge to 40 below zero, while summer days rarely exceed 70 degrees. The persistent souls who call Leadville home have adapted to life in the clouds, where the stars seem close enough to touch and the horizon curves with the weight of mountains. In Alberta's Columbia icefield, the Athabasca Glacier performs a remarkable geographical magic trick. Its meltwater feeds 3 different oceans. This ancient river of ice, part of the largest ice field in the Rocky Mountains, sits at a unique triple divide point. Water from the glacier flows into streams that eventually reach the Arctic Ocean via the Athabasca and Mackenzie rivers, the Atlantic through the North Saskatchewan River and Hudson Bay, and the Pacific through the Columbia River system. This frozen crossroads has been directing water to 3 corners of the continent for thousands of years, though the glacier itself is retreating rapidly, having lost half its volume in the past century. Standing at the toe of the glacier, you can watch water beginning journeys that will end thousands of miles apart in vastly different seas. It's one of nature's most elegant demonstrations of how a single point in the landscape can connect to the entire world. High in the mountains of British Columbia, the Burgess Shale Formation preserves a moment from 508 million years ago with such clarity that it seems almost impossible. These rocks contain fossils so exquisitely preserved that soft tissues, organs, and even the contents of digestive systems remain visible. The creatures preserved here lived during the Cambrian explosion, a period when life was experimenting with forms that seem almost alien today. 5-eyed Opabinia, the fearsome predator Anomalocaris, and dozens of other species that left no modern descendants. The shale formed when mudslides buried these creatures instantly in an oxygen-poor environment at the bottom of an ancient sea. Now, lifted high into the mountains and exposed by erosion, these rocks offer the clearest window we have into a critical moment in evolution. Each fossil is a letter and a message sent across 500 million years, telling us about a world so different from ours that it might as well be another planet. Rocky Mountain National Park in Colorado compresses an entire continent's worth of ecosystems into 415 square miles. Within this relatively small area rise 60 peaks exceeding 12,000 feet, each one an island of alpine tundra floating above tree line. The park spans from montane valleys at 8,000 feet to the windswept summit of Long's Peak at over 14,000 feet. In summer, the high meadows explode with tiny alpine flowers that must complete their entire life cycle in the brief growing season. Elk migrate up and down the mountains with the seasons. Bighorn sheep navigate impossible cliffs, and mountain goats, not native but now established, pick their way across vertical terrain. The park preserves a vertical journey through life zones that would normally require traveling from Colorado to the Arctic. Each 1,000 feet of elevation gain equals roughly 300 miles of northward travel in terms of climate and ecosystem. The Fraser River in British Columbia defies the fundamental logic of mountain rivers by cutting directly through the Rocky Mountains from east to west. This geographical rebellion suggests something profound. The river is older than the mountains themselves. As the Rockies rose, the Fraser kept cutting downward, maintaining its ancient course even as the land lifted around it. The river carved its canyon at the same pace the mountains grew, creating a water-carved gateway through seemingly impenetrable peaks. Today, the Fraser Canyon provides one of the few natural passages through the Canadian Rockies, a route that indigenous peoples used for thousands of years and that later became critical for railways and highways. The river's persistence over millions of years demonstrates one of geology's great principles, that given enough time, water always wins its argument with stone. In Jasper National Park, Medicine Lake performs an annual vanishing act that puzzled observers for generations. Every autumn, this sizable lake simply disappears, draining away through hidden sinkholes in its floor like a massive bathtub with the plug pulled. The water doesn't actually vanish. It flows through one of the most extensive known cave systems in the Canadian Rockies, traveling underground for 16 kilometers before emerging in the Moline Canyon. In spring, snowmelt overwhelms the drainage system, and the lake refills, sometimes reaching depths of 20 meters. This cycle has repeated for thousands of years, creating a lake that exists only half the year. The underground river system beneath Medicine Lake remains largely unexplored, too dangerous for human navigation, but traced by dye tests and the patient work of water. Indigenous peoples long knew of this phenomenon, considering the lake's behavior evidence of powerful medicine, hence its name. The Laramide orogeny, the mountain-building event that created the Rockies, left its most dramatic signature in the Flatirons near Boulder, Colorado. These massive sandstone slabs, some over 90 degrees from horizontal, stand like ancient tombstones against the mountain front. Originally, these rocks lay flat at the bottom of an ancient sea. Then, beginning 70 million years ago, immense tectonic forces thrust them skyward, tilting them to near vertical positions. The Flatirons demonstrate the almost incomprehensible power of continental collision, forces that can take solid rock and stand it on end like playing cards. Today, these tilted slabs create Boulder's distinctive skyline, their smooth faces glowing pink and orange in the setting sun. Rock climbers treat them as vertical playgrounds, following routes that trace the ancient sea bottom turned perpendicular to its original orientation. Each Flatiron is a page from Earth's history book, stood on edge for all to read. Deep beneath Wyoming lies one of North America's great sleeping treasures, the Green River Formation, containing oil shale deposits that represent the compressed remains of an enormous ancient lake system. 50 million years ago, this region was covered by Lake Gossute and Lake Winta, massive bodies of water that persisted for millions of years. As countless generations of algae and other organisms died and settled to the lake bottom, they formed layers of organic rich sediment. Today, these deposits contain an estimated 1.5 trillion barrels of oil locked in rock, theoretically enough to supply the United States for centuries. But this oil remains mostly untapped, trapped in stone that requires more energy to process than conventional drilling. The formation also contains remarkably preserved fossils, including complete fish, insects, and even bird feathers. It's a library of ancient life written in stone and oil, waiting beneath the mountains. In Utah's Fish Lake National Forest grows pando, a single organism that challenges our very conception of what constitutes an individual life. This clonal colony of quaking aspen trees covers 106 acres and weighs approximately 6,600 tons, making it one of the heaviest known organisms on Earth. What appears to be a forest of separate trees is actually a single genetic individual, connected underground by a massive root system. Some scientists estimate pando's root system could be 80,000 years old, possibly much older, making it one of Earth's most ancient living things. Each tree is actually a stem, genetically identical to every other stem in the grove. When autumn comes, the entire organism turns golden as one, creating a patch of synchronized color visible from miles away. Pando, Latin for eye spread, has been slowly expanding across the landscape since before humans developed agriculture. The Rocky Mountain Trench stretches 900 miles from Montana to northern British Columbia, forming one of Earth's longest continuous valleys. This massive geological feature runs so straight that from space, it looks like someone drew a line along the western edge of the Rockies with a ruler. The trench formed along an ancient fault zone where the Earth's crust pulled apart and dropped, creating a valley that in some places reaches depths of a mile below the surrounding peaks. Major rivers, including the Columbia, Fraser, and Kootenai, use portions of this convenient corridor. The trench is so prominent that it's visible from the International Space Station without magnification. For millions of years, it has served as a highway for wildlife, water, and weather, channeling Pacific storms inland and providing a low-elevation route through otherwise impassable mountains. The consistency of its form across nearly 1,000 miles speaks to the enormous scale of the tectonic forces that shaped it. Devil's Tower in Wyoming rises from the prairie like a colossal stone tree stump, its fluted columns reaching 867 feet above its base. This formation began as magma that cooled underground about 50 million years ago. As the magma cooled, it contracted and cracked into distinctive hexagonal columns, similar to how mud cracks when it dries, but on a massive scale. Over millions of years, erosion stripped away the softer sedimentary rocks that once surrounded and covered this igneous intrusion, revealing the tower we see today. The columns that make up the tower are some of the largest on Earth, with some measuring 6 feet in diameter. According to Kiowa legend, the tower was formed when giant bears clawed at the rock trying to reach 7 sisters who were lifted to safety by the rising stone, the claw marks becoming the vertical grooves. Whether explained by science or story, Devil's Tower remains one of the most dramatic examples of how Earth reveals its hidden depths through patient erosion. In Colorado's San Juan Mountains, Wolf Creek Pass receives over 400 inches of snow annually, making it one of the snowiest spots in the Rocky Mountains. This incredible accumulation results from a perfect combination of elevation and orientation to incoming Pacific storms. The pass sits at nearly 11,000 feet, high enough to wring moisture from clouds that have already crossed multiple mountain ranges. Storm systems arriving from the Pacific Ocean rise over the San Juans, cooling and dropping their remaining moisture as snow that can fall from October through May. The snowpack here doesn't just create challenging winter driving conditions, it serves as a frozen reservoir that feeds the Rio Grande and other rivers throughout the summer. Some years, the snow reaches depths of 25 feet or more, burying trees and creating a landscape that looks more like the Arctic than Colorado. This reliable snowfall has shaped the ecology of the region, supporting forests and meadows that depend on the slow release of meltwater through the dry summer months. Glacier National Park in Montana serves as a stark barometer of our changing climate. In 1850, the park contained 150 glaciers. Today, only 26 remain, and scientists predict even these will disappear by 2030. The retreat of these glaciers is happening at a pace visible within a human lifetime. Photographs from just 50 years ago show ice where today there are lakes and bare rock. As the glaciers melt, they reveal landscapes that have been buried under ice for thousands of years, including ancient forests and archaeological sites. The loss of glaciers doesn't just change the scenery, it fundamentally alters the park's ecosystems. Glacial meltwater feeds streams that remain cold through summer, supporting native trout and other cold water species. Without glaciers, these streams warm, water flow becomes irregular, and entire food webs shift. The park's name may soon become a historical artifact, referring to features that no longer exist. The Eisenhower Tunnel, carved through Colorado's Continental Divide, represents one of the most ambitious mountain engineering projects ever undertaken. At 11,158 feet, it holds the distinction of being the world's highest vehicle tunnel. Construction crews worked for years in conditions where altitude sickness was common, rock frequently unstable, and water infiltration constant. The tunnel cuts through rock that was once at the bottom of ancient seas, lifted nearly 2 miles into the sky, and then hollowed out by human determination. Before the tunnel's completion, vehicles had to climb over Loveland Pass, a harrowing journey in winter that claimed many lives. Today, 70,000 vehicles pass through the tunnel daily in summer, traveling under the Continental Divide in minutes rather than hours. The tunnel's ventilation system must constantly work to remove vehicle exhaust from the thin air, where lower oxygen levels make combustion less efficient. On a spring morning in 1925, the Gros Ventre mountainside in Wyoming suddenly gave way, and 50 million cubic yards of rock thundered into the valley below in less than 3 minutes. This massive landslide, one of the largest in recorded North American history, created an instant dam 225 feet high across the Gros Ventre River. The natural dam held for 2 years before catastrophically failing, sending a wall of water downstream that destroyed the town of Kelly. The slide scar remains visible today, a mile-wide amphitheater of exposed rock on the mountainside. The debris from the slide still fills the valley, creating a landscape of chaotic boulder fields and hummocky terrain. Lower Slide Lake, formed behind the remaining portions of the landslide dam, provides a peaceful contrast to the violence of its creation. This event demonstrates how mountain landscapes can change not just over geological time, but in moments of catastrophic readjustment. In Banff National Park, the cave and basin hot springs maintain a constant temperature of 34 degrees Celsius year-round, heated by geothermal processes occurring 2.5 kilometers below the surface. These springs have been a gathering place for thousands of years. Archaeological evidence shows indigenous peoples used them long before European arrival. The springs create a unique microclimate where tropical plants can grow despite the mountain environment, including species of algae and bacteria found nowhere else in Canada. The warm water supports tiny snails found only in Banff's thermal springs, descendants of populations that survived the ice ages in these warm refuges. The dissolved minerals in the spring water have created terraces of tufa, a form of limestone that builds up where the hot water meets the cold mountain air. These springs were the catalyst for creating Canada's first national park, when railway workers stumbled upon them in the 1880s and recognized their potential as a tourist attraction. The Black Canyon of the Gunnison in Colorado plunges into darkness with such determination that it earned its name from the shadows that fill its depths. This narrow gorge drops 2,722 feet in just 48 miles, creating North America's steepest mountain descent. The Gunnison River has been carving this canyon for 2 million years, cutting through rock so hard that the process has been agonizingly slow. The river deepens the canyon by the width of a human hair each year. The walls are so sheer and the canyon so narrow that sunlight reaches the river for only 33 minutes a day in some sections. The rock here is Precambrian basement rock, nearly 2 billion years old. Dark metamorphic stone shot through with pink veins of pegmatite. From the rim, the river below often sounds like distant thunder, its roar echoing between walls that seem to squeeze the sky into a narrow ribbon. The darkness that gives the canyon its name creates a world of permanent twilight at the bottom, where the temperature remains cool even in summer. Montana's Beartooth Highway climbs to nearly 11,000 feet as it crosses some of the most spectacular alpine terrain in North America. The road reaches an elevation of 10,947 feet at Beartooth Pass, crossing 20 peaks that exceed 12,000 feet in just 68 miles of roadway. Built in the 1930s, the highway remains closed 7 months of the year, buried under snow that can reach depths of 20 feet or more. When it opens in late May or June, the road passes between walls of snow that tower above vehicles. The highway crosses a landscape that was completely covered by glaciers just 10,000 years ago, leaving behind a terrain of pristine alpine lakes, polished granite, and meadows that burst with wildflowers during the brief summer. From the highest points, you can see for 100 miles in clear weather, with mountain ranges stretching to the horizon like frozen waves. The road itself seems impossibly placed, switchbacking up seemingly vertical walls and crossing plateaus that feel like the top of the world. The Colorado Plateau performed a geological magic trick over the last 5 million years, rising 5,000 feet without the typical folding and breaking that usually accompanies such dramatic uplift. This massive block of Earth's crust, covering much of Utah and portions of Colorado, Arizona, and New Mexico, rose like a giant elevator, maintaining its internal structure, while the landscape around it deformed and fractured. The plateau's layers of sedimentary rock remained largely horizontal even as they were lifted nearly a mile into the sky. This unusual behavior has created a landscape where ancient seabeds now sit at 7,000 feet elevation, their fossils and ripple marks preserved as if the ocean departed yesterday rather than millions of years ago. Rivers crossing the plateau had to cut deeper and deeper to maintain their courses, creating the spectacular canyons for which the region is famous. The mechanism behind this remarkable uplift remains partially mysterious, though geologists suspect hot mantle material beneath the crust provided the buoyancy for this continental life raft. Lake Minnewanka in Alberta reaches depths of 466 feet, making it the deepest lake in the Canadian Rockies. But beneath its dark waters lies a hidden history, the remains of a resort town submerged when the lake was dammed in 1941. The original lake was much smaller, known to the Stoney Nakoda people as Lake of the Spirits. When divers descend into Minnewanka's depths today, they find the ghostly remains of the flooded town, foundations, bridge pilings, and even intact dam structures from earlier iterations of the reservoir. The lake stretches for 13 miles through a valley carved by ancient glaciers, surrounded by peaks that rise directly from the water's edge. In winter, the lake freezes with ice thick enough to drive on, but methane gas bubbles from decomposing vegetation on the lake bottom create beautiful but dangerous pockets of weakness in the ice. the water remains near freezing year-round, even in summer rarely warming above 4 degrees Celsius in its depths. The Maroon Bells near Aspen, Colorado, stand as perhaps the most photographed peaks in North America, but their beauty masks a deadly secret. These twin 14ers are composed not of solid granite like many Colorado peaks, but of mudstone, compressed mud from an ancient seabed. This sedimentary rock, laid down 300 million years ago, has been baked and compressed, but remains notoriously unstable. Climbers call them the deadly bells because the rock crumbles in your hands, making climbing routes that would be straightforward on solid rock into dangerous endeavors. The mudstone gives the peaks their distinctive maroon color, caused by iron oxides in the rock that rust to deep red. When the morning or evening sun hits these peaks, they glow like embers against the sky. The layers visible on the mountain faces tell the story of an ancient sea that advanced and retreated repeatedly, each cycle adding another stripe to what would become these photogenic but treacherous peaks. Idaho's Craters of the Moon volcanic field spreads across 618 square miles of what looks like an alien landscape dropped into the American West. The most recent lava flows here are merely 2,000 years old, yesterday in geological terms, and the volcanic field remains dormant rather than extinct. The landscape preserves 3 major lava fields from 8 distinct eruptive periods over the last 15,000 years. Walking across this terrain feels like exploring another planet. Rope-like Pahoho lava, jagged Aya flows, and cinder cones rising like small volcanoes from the Black Rock Desert. Despite the harsh appearance, life has found remarkable ways to adapt here. Limber pines grow from cracks in the lava, their roots seeking moisture deep in the rock. In spring, wildflowers bloom in stunning contrast against the black basalt. The lava tubes beneath the surface maintain constant cool temperatures, preserving ice through the summer and creating refuge for various creatures. NASA sent Apollo astronauts here to train for moonwalks, recognizing the landscape's otherworldly character. The Wind River Range in Wyoming compresses 40 peaks over 13,000 feet into a space just 100 miles long, creating one of the most concentrated collections of high mountains in the lower 48 states. Unlike the more famous Tetons to the west, the Wind Rivers maintain a sense of remoteness, with much of the range accessible only by foot or horseback. The range contains 7 of Wyoming's 10 highest peaks, including Gannett Peak, the state's highest point. Glaciers still cling to the north faces of many peaks, feeding streams that eventually reach 3 different oceans. The range forms the headwaters of the Green River, which flows to the Colorado and eventually the Pacific, while other streams feed the Wind River, which becomes the Bighorn, then the Yellowstone, ultimately reaching the Atlantic via the Missouri and Mississippi. The Continental Divide weaves through these peaks like a snake, sometimes following knife-edge ridges where a stumble could send you toward either ocean. Grasshopper Glacier in Montana holds within its ice one of nature's most unusual time capsules, millions of frozen locusts from centuries past. These insects, caught in storms while migrating over the mountains, have been preserved in the glacier's layers like pages in a book. Some of these locusts are several hundred years old, possibly from the same species that created the devastating swarms recorded in pioneer accounts. As the glacier melts, it releases these ancient insects, perfectly preserved by the cold, creating dark bands visible in the ice. Scientists have used these specimens to study how insect populations have changed over time. The glacier itself clings to the northeast face of Grasshopper Peak in the Beartooth Mountains, shrinking each year as climate warms. The locusts embedded in the ice tell a story of massive swarms that once darkened the skies, migrations so vast they could strip entire valleys of vegetation. Today's visitors might find recently exposed specimens at the glacier's edge, ancient travelers finally completing their interrupted journey. Colorado claims 58 peaks exceeding 14,000 feet, more of these 14ers than any other state, though the count itself remains surprisingly controversial. The exact number changes depending on how one defines a separate peak versus a subsidiary summit. Some mountains that seem clearly distinct from one viewpoint appear as mere bumps on a ridge from another angle. The generally accepted criteria require at least 300 feet of prominence. The vertical distance a peak rises from the saddle, connecting it to a higher neighbor. This concentration of high peaks results from Colorado's position at the heart of the Rocky Mountains, where multiple ranges converge. The 14ers spread across 5 different mountain ranges within the state, each with distinct geological character. Some, like the Collegiate Peaks, are relatively gentle giants that can be climbed without technical equipment. Others, like the deadly Capitol Peak, require serious mountaineering skills. Together, they create a high-altitude island ecosystem where plants and animals adapted to Arctic conditions survive thousands of miles south of the Arctic itself. The Absaroka Range, straddling the Wyoming-Montana border, tells a violent volcanic story written in layer upon layer of volcanic rock. For nearly 50 million years, this region experienced almost continuous volcanic activity, building up deposits over 6,000 feet thick. Unlike the sharp, young peaks of the Tetons, the Absarokas show the weathered, rounded profiles of ancient volcanism modified by millions of years of erosion. The volcanic rocks here preserve entire fossilized forests, trees that were buried by volcanic mud flows and turned to stone. In some places, multiple forest layers stack one atop another, each representing a forest that grew, was buried, and was replaced by a new forest growing on the volcanic debris. These petrified forests tell of a time when this region resembled today's Pacific Northwest, with redwoods and other warm climate trees. The Absaroka volcanism coincided with the formation of Yellowstone's first volcanic features, though the current Yellowstone hotspot activity is much younger and unrelated to the Absaroka eruptions. Hell's Half Acre in Wyoming presents a landscape that seems torn from a nightmare. 320 acres of deeply eroded badlands that formed in just 10,000 years. Despite its name, this geological oddity actually covers significantly more than half an acre, spreading across the landscape like an open wound. The formation consists of soft sedimentary rocks that erode rapidly during occasional but intense thunderstorms. Each rain event carves the canyon deeper, creating a constantly changing maze of ravines, caves, and pinnacles. The rock layers exposed here span millions of years, with fossils scattered throughout. Native Americans used the caves for shelter, and outlaws later used the labyrinthine terrain to evade pursuit. The erosion happens so quickly that maps of the trail system become obsolete within years. Some of the ravines drop 60 feet straight down, and the soft rock makes climbing dangerous. From the rim, the formation looks like a miniature mountain range turned inside out, revealing the Earth's interior architecture. Mount Robson in British Columbia rises from valley floor to summit in one tremendous sweep of nearly 10,000 feet, claiming the greatest vertical relief in the Canadian Rockies. Known to First Nations as the Mountain of the Spiral Road, referring to the way clouds spiral around its peak, Robson creates its own weather. The mountain rises so dramatically that it forces air masses upward, creating near constant cloud cover around the summit. climbers report that Robson's summit is clear only about 10% of the time. The mountain's north face presents one of the most challenging climbs in North America, a mile-high wall of ice and rock that wasn't successfully climbed until 1963. The Emperor Face, as this route is known, regularly sheds avalanches that thunder down to the valley below. Despite being lower in absolute elevation than many peaks in Colorado, Robson's massive vertical relief makes it appear far more imposing, a great pyramid of rock and ice that dominates the landscape for 50 miles in every direction. The Lewis Overthrust in Glacier National Park represents one of geology's most spectacular demonstrations of the power of continental collision. Here, rocks 1.5 billion years old rest directly on top of rocks merely 100 million years old, reversing the normal order of younger rocks above older. This occurred when immense tectonic forces pushed an entire slab of Earth's crust up and over younger rocks, sliding it eastward for over 300 miles. The thrust fault created some of Glacier's most dramatic scenery, with ancient Precambrian rocks forming colorful cliff faces above valleys carved in younger Cretaceous rock. The overthrust was so gentle in geological terms that the rock layers remained largely intact, creating a situation where you can place your hand on a single surface and touch rocks separated by over 1 billion years of Earth history. This same thrust created similar features throughout the northern Rockies, but nowhere is it more dramatically displayed than in Glacier's peaks. Blue Mesa Reservoir spreads across Colorado's western valleys, containing 940,000 acre-feet of water when full, making it the state's largest body of water. Created by damming the Gunnison River, the reservoir drowns a landscape that tells a remarkable geological story. The surrounding hills display bands of blue-gray shale that give the reservoir its name, rocks formed from volcanic ash that fell here 70 million years ago. When the water level drops during drought years, it reveals a landscape of castles and spires carved from this soft rock, formations that are slowly being destroyed by the reservoir's fluctuating water levels. The reservoir sits at 7,500 feet elevation, and in winter, it freezes thick enough to support ice fishing shanties. The water's deep blue color comes from dissolved minerals and the reflection of the often cloudless Colorado sky. From above, the reservoir's many arms reach into side canyons like the fingers of a giant hand grasping the landscape. The Teton Range in Wyoming represents youth in mountain terms, having risen to their current heights in just the last 2 million years, making them the youngest mountains in the Rocky Mountain chain. This rapid uplift, continuing today at measurable rates, created their distinctive profile, a wall of jagged peaks rising directly from the valley floor without foothills. The Teton Fault, along which this uplift occurs, has created over 7,000 feet of vertical displacement, though erosion has reduced the visible relief to about 6,000 feet. The mountains continue to grow, punctuated by earthquakes that remind us the process is ongoing. Unlike most Rocky Mountain ranges that rose during the Laramide orogeny 70 million years ago, the Tetons are relative newcomers, their sharp, unweathered peaks still showing the angular profiles of geological youth. The rapid uplift has exposed rocks ranging from 3 billion-year-old basement rock to relatively recent sedimentary layers, creating a compressed timeline of Earth history in a single mountain face. The fluorescent fossil beds in Colorado preserve an entire ecosystem from 34 million years ago with such detail that scientists can study not just what lived there, but how the ecosystem functioned. A massive volcanic eruption from the Guffey Volcanic Center buried a lush valley under 15 feet of ash in a matter of days. The fine volcanic ash preserved everything it touched. Insects with wing patterns still visible, leaves with their cellular structure intact, even spider silk and butterfly scales. The fossil beds have produced over 50,000 specimens representing over 1,800 species. Among the most spectacular are petrified redwood stumps, some over 40 feet in circumference, from trees that once towered over 200 feet tall. This was a time when Colorado's climate resembled modern California, with redwoods, palms, and other warm climate species. The preservation is so fine that scientists have identified insects down to the species level and can even determine what some of them had eaten based on their fossilized gut contents. Utah's Timpanogos cave system maintains a constant 45-degree Fahrenheit temperature throughout the year, regardless of the outside conditions that can range from 20 below zero to over 100 degrees. This remarkable stability results from the cave's position within the mountain and the insulating properties of limestone. The caves formed over millions of years as slightly acidic groundwater dissolved passages through the limestone of Mount Timpanogos. Today, these passages are decorated with formations that seem to defy gravity. Stalactites and stalagmites, of course, but also helictites that spiral and branch in impossible directions, growing against gravity due to capillary forces. The caves were discovered when a mountain lion's tracks in early snow led a tracker to the entrance. Inside, the formations create a natural cathedral of stone, with colors ranging from pure white to deep amber, depending on the minerals present when each formation grew. Some formations are still actively growing, adding perhaps a cubic inch of material every century. The Bitterroot Mountains, forming the boundary between Idaho and Montana, contain some of Earth's oldest exposed rocks, granite and metamorphic formations dating back 1.6 billion years. These ancient rocks formed when the only life on Earth was single-celled organisms in the oceans. The Bitterroots represent the eroded roots of mountains that stood here long before the current Rockies existed, mountains that were worn down to nothing and then lifted again. The range takes its name from the bitterroot flower, which grows in seemingly impossible conditions in rocky soil throughout the mountains. The Continental Divide follows the crest of the bitterroots for much of their length, creating a barrier that captures moisture from Pacific storms on the western slopes while leaving the eastern valleys in rain shadow. The difference is dramatic. Lush cedar forests on the west give way to dry grasslands on the east, sometimes within just a few miles. Grand Mesa in Colorado rises above the surrounding landscape as the world's largest flat-topped mountain, covering 500 square miles at an elevation of 10,000 feet. This massive elevated platform formed from lava flows that covered the area 10 million years ago. The hard basalt cap protected the softer rocks beneath from erosion, while the surrounding landscape was carved away, leaving the mesa standing like a giant table above western Colorado. The top of Grand Mesa holds over 300 lakes, created by glacial action during the ice ages. From the rim, you can see for over 100 miles on clear days, with the Colorado River Valley spread out far below. The mesa creates its own weather patterns, often wrapped in clouds, while the valleys below bask in sunshine. In winter, the mesa receives over 300 inches of snow, creating a high-altitude winter wonderland that persists well into summer. The flat top supports forests and meadows that seem impossibly placed, an entire ecosystem floating 2 miles above sea level. Wyoming's Granite Mountains harbor Sherman granite, a stone so ancient it formed 1.4 billion years ago when complex life had not yet emerged on Earth. This pink-hued granite has become prized worldwide as dimension stone, shipped to buildings and monuments across continents. The granite's exceptional hardness and resistance to weathering come from its slow cooling deep underground, allowing large crystals to form in perfect interlocking patterns. When polished, the stone reveals a constellation of minerals: pink feldspar, clear quartz, and black biotite, creating a pattern that seems almost deliberately artistic. The Sherman granite tells a story of immense pressure and heat, of minerals crystallizing from molten rock miles beneath an ancient surface that no longer exists. Quarries here have supplied stone for state capitals and federal buildings, each block a piece of deep time made useful. The granite weathers into rounded boulders and balanced rocks scattered across the landscape like giant marbles left by playful gods. These formations create a moonscape of stone where the bedrock of the continent lies exposed to sky. The Sangre de Cristo Range earned its name, Blood of Christ, from Spanish explorers who witnessed the mountains glow deep red in the light of sunrise and sunset. This remarkable alpenglow results from iron oxide in the rock, essentially rust that catches and amplifies the warm wavelengths of light during the golden hours. The range stretches from southern Colorado into northern New Mexico, forming the southern terminus of the Rocky Mountains. At these times of day, the peaks seem to burn without heat, a cold fire that transforms gray stone into something that appears almost alive. The phenomenon is most dramatic after fresh snow, when the white surface reflects and intensifies the colored light. Ancient Puebloan peoples considered these mountains sacred, and watching them ignite at dawn, it's easy to understand why. The red glow can last for minutes or mere seconds, depending on atmospheric conditions. Sometimes the mountains pulse through a spectrum of colors, gold to orange to red to purple, as if the stone itself were breathing. This daily transformation has inspired artists and mystics for centuries, a reminder that even solid rock can appear transformed by something as simple as angled light. Takakau Falls in Yoho National Park plunges 1,224 feet from a hanging valley, making it Canada's second highest waterfall. The name Takakau comes from the Cree language, expressing awe and wonder, roughly translating to, "It is magnificent." Fed by the daily glacier, the falls change character with the seasons and even the time of day. In early summer afternoons, when the sun melts the glacier most rapidly, the falls thunder with maximum force, sending spray hundreds of feet from the base. By dawn in autumn, the flow reduces to a whisper, and in winter, it becomes a massive ice sculpture, drawing ice climbers from around the world. The hanging valley from which the water falls was carved by a tributary glacier that couldn't cut as deeply as the main valley glacier, leaving its valley suspended high on the cliff face. The mist from the falls creates perpetual rainbows on sunny days and supports a lush grove of old-growth forest at its base, trees that thrive in the constant moisture. Standing at the base, looking up at water that seems to fall from the sky itself, you feel the mountain breathing in mist and thunder. The belt supergroup rocks scattered across Montana and Idaho preserve stromatolites, fossilized mats of ancient algae that represent some of Earth's earliest experiments with life. These formations date back 1.4 billion years, when the only living things on our planet were microscopic organisms in shallow seas. The stromatolites appear as layered domes and columns in the rock, each layer representing countless generations of cyanobacteria that grew, died, and were covered by sediment. These humble organisms were Earth's first ecosystem engineers, producing oxygen that would eventually transform the atmosphere and make complex life possible. Today, you can place your hand on these rocks and touch the preserved remains of life forms that existed when a day lasted only 18 hours and the moon loomed much larger in the sky. The belt rocks stretch across thousands of square miles, colored in subtle shades of green, purple, and red from various mineral content. Some formations preserve ripple marks from ancient waves, mud cracks from dried tidal flats, and even raindrop impressions from storms that fell over 1 billion years ago. Mount Evans Road in Colorado climbs to 14,130 feet, claiming the title of North America's highest paved road. The journey from Idaho Springs to the summit rises over 7,000 feet in just 28 miles, passing through multiple life zones equivalent to driving from Denver to the Arctic Circle. At the summit, visitors find themselves in an environment where the air contains only 60% of sea level oxygen, where water boils at a lower temperature, and where summer temperatures rarely exceed 50 degrees. Mountain goats, introduced to the area in the 1960s, now traverse the parking areas with casual indifference to gasping tourists. The road, originally built as a scenic byway in the 1920s, closes each winter under dozens of feet of snow. When it reopens in late May, crews must cut through snow walls 20 feet high. From the summit on clear days, you can see for over 200 miles, with the Great Plains stretching endlessly eastward while rank upon rank of mountains march toward the western horizon. The Summit House, built from native stone, provides shelter from winds that can exceed 100 miles per hour. The Canadian Rockies form a vast repository of ice, containing over 1,000 glaciers that cover approximately 1,500 square miles of terrain. This represents one of the largest accumulations of ice south of the Arctic Circle, though it's diminishing rapidly. These glaciers range from massive ice fields, like the Columbia Icefield, to tiny pocket glaciers clinging to north-facing cirques. Together, they store enough water to cover the entire province of Alberta to a depth of several inches. The glaciers act as frozen rivers, flowing imperceptibly downhill, carving valleys and grinding rocks to flour fine sediment that gives alpine lakes their distinctive turquoise color. Many of these glaciers have been flowing continuously for thousands of years, their ice containing trapped air bubbles that preserve samples of ancient atmosphere. As they melt, they release this ancient air, along with seeds, pollen, and even bacteria that have been frozen for millennia. The sound of glaciers is distinctive, creaking, groaning, and occasionally thundering as ice breaks and shifts. Each glacier has its own personality, its own pattern of crevasses and seracs, its own rate of flow. Wheeler Peak rises in northern New Mexico as the state's highest point at 13,161 feet, marking the southernmost extent of alpine tundra in North America. Above 11,000 feet, the mountain supports a fragile ecosystem typically found thousands of miles to the north. Arctic plants like moss campion and alpine forget-me-nots bloom in the brief summer, while white-tailed ptarmigan, birds usually associated with Alaska, make their southernmost home here. The peak stands at a biological crossroads where northern and southern species meet at the extremes of their ranges. Bristlecone pines near treeline may be over 2,000 years old, their twisted forms sculpted by centuries of wind and ice. The mountain creates its own weather, often clouded when surrounding peaks are clear. Snow can fall any month of the year at the summit, and afternoon thunderstorms in summer arrive with frightening regularity. From the peak, the view encompasses the transition from rocky mountains to high desert, a geography lesson written in stone and distance. The Sangre de Cristo Range, of which Wheeler is part, ends just south of here, making this truly the southern frontier of Rocky Mountain alpine environments. The Madison River below Hebgen Dam in Montana maintains unusually warm temperatures year-round, creating a unique ecosystem in the shadow of Yellowstone. Geothermal features upstream, particularly in Yellowstone's geyser basins, add warm water to the river system. This thermal input keeps sections of the river from freezing, even when air temperatures plunge to 40 below zero. Steam rises from the water on cold mornings, creating an ethereal landscape where trumpeter swans and other waterfowl gather in the warm stretches through winter. The consistent temperatures support a remarkable fishery, with trout growing larger and faster than in typical mountain streams. Aquatic insects thrive in the warm water, hatching throughout the year and providing constant food for fish and birds. The river's warmth extends its influence beyond the water itself, creating microclimates along the banks where plants grow that shouldn't survive at this elevation and latitude. Eagles and osprey fish these waters year-round, finding open water when other rivers are locked in ice. The thermal influence gradually dissipates as the river flows north, but for miles below the dam, the Madison exists as an oasis of warmth in the cold mountain landscape. Medicine Bow Peak in Wyoming contains quartzite of such exceptional purity that it was once quarried specifically for glassmaking. This metamorphic rock began as beach sand 500 million years ago, was buried and compressed into sandstone, then transformed by heat and pressure into quartzite so pure it's nearly 100% silica. The rock appears almost white, sometimes with a subtle pink or purple tinge from trace minerals. When struck, it rings like a bell, and Native Americans used pieces as tools because the rock fractures with edges sharper than steel. The quarrying operations of the early 20th century left scars still visible on the mountain, though nature is slowly reclaiming these wounds. The quartzite's hardness means it erodes very slowly, which is why Medicine Bow Peak stands prominently above the surrounding terrain. In certain light, the peak seems to glow, the white rock reflecting sunlight like snow even in summer. The transformation from sand to stone represents a journey through deep time and deep earth, pressure and heat working their alchemy to create something entirely different from its origin. Colorado's Front Range presents a meteorological paradox, receiving over 300 days of sunshine annually, while accumulating 100 inches or more of snow at higher elevations. This seemingly impossible combination results from the region's particular geography and weather patterns. Storms typically arrive at night and clear by morning, dropping heavy snow and darkness while leaving days crystal clear. The mountains force Pacific storms upward, wringing out moisture on west-facing slopes, but the storms often dissipate by daybreak. Winter high-pressure systems create temperature inversions that trap clouds in valleys while summits bask in sunshine above the cloud deck. This abundance of sun at high elevation creates intense UV radiation, sunburn being possible even in winter. The combination of deep snow and bright sun creates unique conditions: powder snow that sublimates directly to vapor without melting, trees plastered white on one side while bare on the other, and a landscape that can be simultaneously Arctic and desert-like. Ski resorts here market both their snow totals and their sunny days, a combination found in few other places on Earth. Mieta Hot Springs in Jasper National Park emerge at nearly 54 degrees Celsius, the hottest springs in the Canadian Rockies. The water begins its journey as rain and snow on the surrounding peaks, seeping through cracks and faults to depths of nearly 3 kilometers. At such depths, Earth's internal heat warms the water, which then rises through other faults, emerging thousands of years after beginning its underground journey. The springs deposit minerals as they cool, creating terraces of travertine and coating rocks with colorful mineral deposits, yellow sulfur, white calcium carbonate, and orange iron oxides. The original springs, now dry, left behind massive tufa deposits that tell of different flow patterns over millennia. The hot water supports unique ecosystems of thermophilic bacteria and algae, organisms that thrive in temperatures that would kill most life. These microscopic communities paint the rocks around the springs in brilliant colors: emerald greens, rust reds, and golden yellows. Indigenous peoples knew of these springs for thousands of years, considering them sacred healing waters. The spring's location, deep in a valley surrounded by peaks, creates a natural amphitheater where steam rises like incense toward the mountain sky. Utah's Uinta Mountains break the rules of Rocky Mountain geography by running east-west for 150 miles, the only major range in the Rockies that doesn't follow the north-south continental grain. This unusual orientation results from unique tectonic forces that created an east-west uplift rather than the typical north-south compression. The range's axis runs perpendicular to prevailing storm tracks, causing it to wring exceptional amounts of moisture from passing weather systems. The Uintas contain Utah's highest peak and the highest peaks in the contiguous United States that don't follow the Continental Divide. Much of the range sits above treeline, creating the largest alpine area in the southern Rockies. Over 1,000 lakes dot the high basins, most carved by glaciers and too cold to support fish without human stocking. The east-west orientation creates dramatically different conditions on north versus south slopes, Arctic conditions on north faces, while south faces support near-desert vegetation. This orientation also made the range a formidable barrier to early travel, forcing pioneers to go around rather than through. The Sawatch Range in Colorado achieves a remarkable concentration of altitude, containing 15 peaks over 14,000 feet within just 50 miles. This assemblage includes Mount Elbert, the Rockies' highest peak, and Mount Massive, which has more area above 14,000 feet than any other peak in the contiguous United States. The range formed from a large batholith, an immense blob of granite that cooled slowly underground and was later exposed by erosion. This granite core gives the peaks their rounded, massive appearance, contrasting with the jagged sedimentary peaks found elsewhere in Colorado. The name Sawatch derives from a Ute word meaning blue earth, referring to the blue-gray sage that covers lower elevations. The range creates a massive wall running north-south through central Colorado, forcing moisture-bearing storms to rise and drop their precipitation, creating a rain shadow that extends all the way to Kansas. Despite their heights, many Sawatch peaks can be climbed without technical equipment, their gentle slopes hiding the fact that summits sit at altitudes where commercial aircraft cruise. Montana's Gates of the Mountains presents a spectacular illusion along the Missouri River, where 1,200-foot limestone cliffs appear to open and close as boats navigate the channel. Meriwether Lewis named this feature during the Lewis and Clark expedition, writing that the cliffs seemed to part for their passage, then close behind them. The illusion results from the river's winding course through perfectly aligned cliff faces, creating perspective shifts that make solid rock appear to move. The limestone here formed from ancient sea deposits, then was tilted nearly vertical by the same forces that created the Rocky Mountains. These cliffs support one of the largest breeding populations of golden eagles in the region, the birds nesting on ledges impossible for predators to reach. The canyon creates its own microclimate, temperatures often 10 degrees warmer than surrounding areas due to heat retained by the rock walls. In certain light conditions, The limestone glows golden, and the river reflects the cliffs so perfectly that the boundary between water and air seems to disappear. The indigenous name for this place translates to stone gates, suggesting the illusion has captivated observers for millennia. The Snake River near Alpine, Wyoming, demonstrates the persistent power of water over rock, cutting a canyon 2,000 feet deep through the Rocky Mountains. The river predates the mountains it cuts through, maintaining its course as the land rose around it. This antecedent river kept pace with uplift, sawing through rock as fast as tectonic forces could raise it. The canyon walls reveal millions of years of geological history, layer by layer, like a textbook opened to chapters written in stone. The river runs cold and clear from Jackson Lake, carrying snowmelt from the Tetons and surrounding ranges. In the canyon, the river's gradient increases dramatically, creating rapids that challenge whitewater enthusiasts. The depth of the canyon creates dramatic temperature inversions, with cold air pooling at river level while warm air sits above. Golden eagles and prairie falcons nest in the cliff faces, while river otters play in the rapids below. The canyon serves as a crucial wildlife corridor, allowing animals to move between the greater Yellowstone ecosystem and ranges to the south, a biological highway carved by water. Rabbit Ears Peak in Colorado stands as a monument to volcanic persistence, twin spires of volcanic rock that resisted 20 million years of erosion while softer surrounding rock wore away. These distinctive formations, resembling their namesake from certain angles, are volcanic plugs, solidified lava that once filled the throats of volcanoes. The surrounding volcanic cones, made of looser ash and cinders, eroded away over millions of years, leaving only these harder cores standing. The rocks here tell of a time when this part of Colorado was violently volcanic, with eruptions building peaks that have long since disappeared. Today, the peaks serve as a prominent landmark, visible for 50 miles in clear weather. The volcanic rock weathers into unusual formations, balanced rocks, narrow pinnacles, and caves where softer rock has eroded from beneath harder caprock. The peaks create their own weather patterns, often catching clouds that mist surrounding mountains. In winter, rime ice forms fantastic sculptures on the exposed rock, creating temporary artworks that last until the next warm wind. The Peace River performs a remarkable feat of fluvial determination, being the only river that completely crosses the Rocky Mountains from east to west in Canada. This river predates the mountains it crosses, maintaining its westward course as the Rockies rose around it. Starting in the Rocky Mountain Trench in British Columbia, the Peace cuts directly through the Continental Divide, flowing through valleys that seem impossibly placed. The river's course suggests it formed when the landscape was entirely different, possibly following a valley that existed before the current mountains. As the mountains rose, the river cut downward at the same pace, maintaining its ancient path. The Peace River Valley creates a low-elevation corridor through the mountains, historically allowing plants and animals to migrate between the interior plains and the Pacific slope. The valley's unique position creates unusual weather patterns, channeling Pacific air masses inland and moderating temperatures in a region that would otherwise be much colder. Today, the river's course through the mountains has been altered by dams, but the ancient valley remains, a testament to water's patient persistence. Idaho's Bora Peak demonstrated the ongoing geological activity of the basin and range when it suddenly rose 1 foot and shifted 11 feet horizontally during a single earthquake in October 1983. This magnitude 6.9 earthquake created a 21-mile-long fault scarp still visible today, a fresh scar on the landscape showing exactly how mountains grow. not smoothly, but in violent jerks separated by long periods of quiet. The earthquake dropped the valley floor while raising the mountain, increasing Bora's prominence as Idaho's highest peak. The fault scarp reveals the mountain's internal structure, exposing rocks normally hidden underground. Trees that once grew in straight lines now show dramatic offsets where the fault moved. The earthquake was felt from Salt Lake City to Spokane, reminding residents that the seemingly stable mountains are still actively growing. The fresh scarp is already beginning to erode, but it will remain visible for thousands of years, a ruler measuring the mountain's growth. Similar earthquakes over millions of years have created the basin and range topography, each event adding inches or feet to mountain heights, while dropping valleys incrementally lower. The Waterton Glacier International Peace Park spans over 1 million acres across the United States-Canada border, creating the world's first international peace park. This designation recognizes that nature knows no political boundaries. The same glaciers carved valleys on both sides of the border. The same wildlife populations move freely between nations, and the same geological forces shaped the entire landscape. The park protects one of the most intact ecosystems in the temperate zones, where grizzly bears, wolves, and mountain lions still inhabit their historical ranges. The international border runs straight through the park, marked only by a 20-foot wide swath cut through the forest. The park's creation in 1932 represented a radical idea that two nations could jointly protect a landscape for its natural values rather than exploiting its resources. Today, wildlife migrations ignore the international boundary, with elk, bears, and wolves moving between countries as seasons and food sources dictate. The parks share geology that tells the same story on both sides of the border. Ancient seafloor lifted into mountains, sculpted by ice, and inhabited by creatures that recognize no human boundaries. Garden of the Gods in Colorado displays massive sandstone fins tilted to near vertical angles, created by the same tectonic forces that raised Pikes Peak to the west. These red rock formations once lay horizontal at the edge of an ancient mountain range that preceded the current Rockies. When the modern mountains rose about 65 million years ago, these sedimentary layers were tilted up like books leaning on a shelf. The rocks range in age from 300 million to 65 million years old, representing different environments from ancient seas to sand dunes. The distinctive red color comes from iron oxide coating the sand grains, essentially rust that formed when iron-rich minerals weathered in ancient desert conditions. Erosion has sculpted the tilted rocks into fantastic shapes. Balanced rocks that seem to defy gravity, windows worn through fins, and spires that point skyward like Gothic cathedral towers. The contrast between the red rocks and Pikes Peak's gray granite creates one of Colorado's most photographed landscapes. The fins channel wind into powerful gusts, and their thermal mass creates microclimates where desert plants grow at the foot of a 14er. The Bob Marshall Wilderness in Montana encompasses 1.5 million acres where no roads penetrate and no motors disturb the silence. This vast preserve, known simply as the Bob to locals, represents one of the most complete ecosystems in the lower 48 states. Here, grizzly bears still follow ancient paths their ancestors walked for thousands of years, and wolves hunt elk through valleys that have never known the sound of engines. The Chinese Wall, a 1,000-foot-high escarpment running for 12 miles along the Continental Divide, forms the wilderness's most dramatic feature, a limestone reef that once lay beneath tropical seas. The wilderness contains the headwaters of 3 major river systems, birthplaces of waters that will reach the Pacific, the Gulf of Mexico, and Hudson Bay. In winter, The interior valleys can record temperatures of 50 below zero, while summer brings explosions of wildflowers to alpine meadows. The absence of human infrastructure means that traveling here requires accepting nature's terms: river crossings without bridges, navigation without signs, and distances measured in days rather than hours. This is landscape as it existed before human alteration, a baseline for what wild truly means. Wyoming's Vidauwu rocks contain some of Earth's most ancient exposed bedrock, granite that crystallized 2.5 billion years ago when the planet was young and alien. These rounded formations, scattered across the landscape like enormous skulls, formed deep underground and were exposed through eons of erosion. The granite here is among the oldest in North America, predating complex life by 2 billion years. Weathering has created fantastic shapes, balanced rocks that seem ready to topple but have stood for millennia, narrow slots between boulders that create natural corridors, and smooth domes that rise from the earth like the backs of sleeping giants. The name Vidauwu comes from the Arapaho word meaning earthborn, reflecting indigenous recognition of these rocks' primordial nature. The granite surface often displays a honeycomb pattern called taphony, created by salt crystallization and freeze-thaw cycles working over thousands of years. Lichens paint the rocks in subtle colors: orange, green, and black, each patch representing decades or centuries of slow growth. Rock climbers prize these formations for their solid holds and crack systems, though the ancient granite can be friable, crumbling under pressure. Mount Assiniboine pierces the sky at 11,870 feet, earning its title as the Matterhorn of the Rockies through its nearly perfect pyramidal form. This mountain stands on the Continental Divide between British Columbia and Alberta, visible from over 30 miles away on clear days. The pyramid shape resulted from glacial erosion on all sides, with glaciers carving away the mountain like sculptors, revealing a form hidden in stone. The mountain creates its own weather system, with clouds forming around the peak even on otherwise clear days. These lenticular clouds, shaped like flying saucers, indicate powerful winds aloft and warn climbers of dangerous conditions. The standard climbing route gains over 5,000 feet from base camp to summit, passing through some of the most exposed terrain in the Canadian Rockies. The mountain's indigenous name translates to "those who cook by placing hot rocks in water," referring to the Assiniboine people who traveled through these valleys. The peak stands surrounded by a collection of pristine alpine lakes, their turquoise waters reflecting the mountain's image on calm mornings, doubling its presence in the landscape. The Rio Grande begins its nearly 2,000-mile journey to the Gulf of Mexico, high in Colorado's San Juan Mountains, born from snowmelt at 12,000 feet. The river starts as a trickle you could step across, gathering strength from hundreds of mountain streams as it descends. In its first 50 miles, the river drops 8,000 feet, rushing through valleys carved by ancient glaciers. The Rio Grande's headwaters lie in the Weminuche Wilderness, where the Continental Divide wraps around the river's source in a horseshoe of peaks. From these mountains, the river flows through the San Luis Valley, one of the world's largest high-altitude valleys, before entering the Rio Grande Gorge in New Mexico. This beginning in the Colorado Rockies seems impossibly distant from the river's end at the Mexican border, where it enters the Gulf as a wide, warm, slow-moving stream. The transformation from alpine brook to desert river represents one of North America's great geographical journeys. The river's course has been flowing for millions of years, predating the current configuration of mountains and maintaining its path through dramatic changes in climate and landscape. Dinosaur Provincial Park in Alberta has produced fossils from 44 different dinosaur species, within just 28 square miles, making it one of the richest dinosaur fossil sites on Earth. 75 million years ago, this was a subtropical coastal plain where rivers meandered to an inland sea. The environment was perfect for preserving fossils. Floods regularly buried carcasses in sediment before they could decay. Today, the badlands here expose these ancient deposits, and erosion constantly reveals new specimens. Complete skeletons, nests with eggs, and even preserved skin impressions emerge from the layered rock. The park has produced over 150 complete dinosaur skeletons, now displayed in museums worldwide. The sediments preserve not just dinosaurs, but an entire ecosystem: crocodiles, turtles, fish, and plants that shared this ancient world. Each layer of rock represents a different moment in time, pages in a story written over millions of years. Walking through the Badlands feels like traveling through deep time, with each step potentially revealing creatures that lived before the Rocky Mountains existed. Deep in Colorado's Black Canyon, sunlight reaches the Gunnison River for only 33 minutes per day in some sections, creating a realm of perpetual twilight. The canyon's extreme depth relative to its narrow width creates this phenomenon. Walls so close and so high that the sun's arc across the sky barely allows light to penetrate. In these shadowed depths, the temperature remains cool even in summer, and unique ecosystems have developed in the absence of direct sunlight. Mosses and ferns grow in the perpetual shade, species typically found in much wetter climates. The brief daily illumination creates a moving spotlight that crosses the canyon floor, a moment of brilliance in an otherwise darkened world. The lack of sunlight has preserved the canyon's walls from the freeze-thaw cycles that weather other formations, maintaining nearly vertical cliffs. The darkness gives the canyon its name, but it also creates its mystery. A place where noon feels like dusk and where the river's roar echoes in shadowed space. The Crow's Nest Pass, at 4,449 feet, represents the lowest crossing of the Continental Divide used by a Canadian transcontinental railway, a geographic gift that opened the West to development. This relatively gentle pass through the otherwise formidable wall of the Rockies has been used for thousands of years, first by indigenous peoples, then by fur traders, and finally by railways. The pass channels Pacific weather systems inland, creating unusual conditions where coastal rainforest species grow much farther east than elsewhere. Wind funneling through the pass can reach hurricane force, with the region experiencing more high wind events than anywhere else in Canada. The nearby Frank Slide and Turtle Mountain stand as reminders of the geological instability of this region, where mountains are still settling into place. Coal deposits in the pass led to extensive mining, with ghost towns now dotting the valley, where once thriving communities extracted the compressed remains of ancient forests. The pass serves as a biological corridor, allowing species from different ecosystems to mingle in ways impossible elsewhere. Utah's Kings Peak rises to 13,534 feet as the state's highest point, surrounded by 11 other peaks exceeding 13,000 feet in the Uinta Mountains. This concentration of high peaks in the unusual east-west trending range creates an alpine island ecosystem. The approach to Kings Peak requires a 16-mile hike just to reach base camp, making it one of the most remote state high points in the contiguous United States. The summit plateau supports Arctic plants that survive in soil that freezes every night of the year, even in summer. From the top, the view encompasses the entire Uinta Range stretching east and west, a sight unique among Rocky Mountain peaks that typically offer north-south vistas. Ancient glaciers carved deep basins around Kings Peak, now filled with over a dozen pristine alpine lakes. The remoteness has preserved the area's wilderness character. Mountain goats, reintroduced in the 1960s, now thrive here, and the lakes contain native cutthroat trout populations that have remained genetically pure. The mountain's isolation means that weather can change rapidly with no escape route, making it one of the more challenging state high points despite the lack of technical climbing. The Frank Slide in Alberta stands as North America's deadliest landslide when 90 million tons of limestone broke free from Turtle Mountain in 100 seconds on April 29, 1903. The massive slab of rock, half a mile wide and several hundred feet thick, traveled down the mountain at over 70 miles per hour, crossing the valley and climbing the opposite side. The debris spread over 3 square miles, burying part of the mining town of Frank and killing over 90 people. Today, the slide path remains clearly visible, a gray scar on Turtle Mountain where the limestone broke away. The debris field, known as the Frank Slide Interpretive Center, looks like a frozen river of massive boulders, some the size of houses. Scientists believe the slide was triggered by the mountain's unusual geology, a steep anticline with weak shale layers beneath harder limestone, combined with coal mining that may have destabilized the base. The mountain continues to be monitored, with sophisticated equipment detecting the slightest movement. The slide remains a reminder of how quickly mountain landscapes can change and how human activity can trigger geological events. The water systems of Glacier National Park in Montana and Waterton Lakes in Alberta share a remarkable hydrological connection, with water taking 7,000 years to complete its cycle through the system. Precipitation falling on the peaks seeps into the limestone and travels through deep aquifers, emerging millennia later in springs and seeps. This ancient water, filtered through miles of rock, emerges crystal clear and cold, having been isolated from the surface for longer than human civilization has existed. The parks sit atop the Lewis Overthrust, where ancient rocks were pushed over younger formations, creating a complex underground plumbing system. Some springs in the parks discharge water that fell as rain when the Egyptian pyramids were being built. This slow circulation means that today's pollution won't affect some water sources for thousands of years, but also that contamination, once introduced, could persist for millennia. The long residence time creates unique chemistry in the emerging water, with high mineral content from prolonged contact with rock. Understanding this ancient water cycle has become crucial for protecting the park's aquatic ecosystems. The Spanish Peaks in Colorado rise from the plains surrounded by 500 volcanic dikes radiating outward like spokes from a wheel, creating one of the world's most spectacular examples of radial dike systems. These dikes formed when magma forced its way into cracks radiating from the volcanic centers 25 million years ago. The magma cooled into harder rock than the surrounding sediments, and erosion has since removed the softer rock, leaving walls of volcanic rock standing up to 100 feet high and extending for miles across the landscape. From above, the pattern resembles a giant spider web or a child's drawing of the sun with rays extending outward. Some dikes run perfectly straight for 14 miles, natural walls that early Spanish explorers called walls of the devil. The dikes create unique ecosystems, with different vegetation growing on either side due to variations in water retention and sun exposure. Native Americans use these natural walls as travel guides and defensive positions. The Spanish Peaks themselves, two prominent mountains rising over 13,000 feet, served as landmarks for travelers on the Santa Fe Trail, visible from over 100 miles away on clear days. Wyoming's Bighorn Basin preserves a remarkable transformation story in its colorful Badlands, a landscape that was tropical swampland 50 million years ago. During the Eocene epoch, this basin resembled today's Louisiana bayous, complete with crocodiles, palm trees, and primitive horses the size of dogs. The Willwood Formation here contains one of the most complete fossil records of mammal evolution following the dinosaurs' extinction. Layers of red, purple, yellow, and gray rock tell of changing climates and environments, river channels, floodplains, and swamps that shifted positions over millions of years. The basin's colors come from different oxidation states of iron in the sediments, with red indicating dry conditions when the sediment was deposited and gray showing wetter periods. Today, this painted desert receives less than 8 inches of rain annually, a dramatic contrast to its swampy past. Erosion continues to expose new fossils, and paleontologists discover new species regularly. The basin sits over a mile high, lifted from sea level by the same forces that created the Rocky Mountains, carrying its tropical past into the cold, dry present. The Mackenzie River system drains 1/5 of Canada, including much of the eastern slopes of the Canadian Rockies, carrying water nearly 3,000 kilometers to the Arctic Ocean. This vast watershed, second only to the Amazon in the Americas, begins in the Rocky Mountains and gathers water from an area larger than Mexico. The river system includes Great Slave Lake, one of the world's deepest lakes, and Great Bear Lake, the largest lake entirely within Canada. The Mackenzie carries sediment from the Rockies all the way to the Arctic, building a massive delta where the river meets the Beaufort Sea. In spring, ice breakup on the river can be violent, with house-sized chunks of ice grinding and crashing as they move north. The river flows through multiple climate zones, from temperate mountains through boreal forest to Arctic tundra. Its tributaries include rivers that flow from glaciers in the Rockies, carrying glacial flour that colors the water milky blue-green. The system has been flowing north since the Rockies formed, one of the few major rivers that maintained its course through multiple ice ages. Colorado's Slumgullion earthflow has been moving continuously for 700 years, currently creeping downhill at about 20 feet per year. This 4-mile-long mass of mud and rock represents one of the best examples of an active earth flow in the world. The flow began when volcanic rocks on the side of Mesa Seco became saturated and began to move, and it has been in constant, slow motion ever since. The earth flow dammed the lake fork of the Gunnison River, creating Lake San Cristobal, Colorado's second-largest natural lake. Trees growing on the flow lean at crazy angles as the ground beneath them shifts, creating a drunken forest effect. Scientists use GPS stations to track the flow's movement, which varies with seasonal moisture. In wet years, it speeds up. In dry years, it slows but never stops. The surface of the flow is hummocky and irregular, with pressure ridges and depressions that change position over time. Walking on the earth flow feels unsettling, knowing that the ground beneath is in motion, even if imperceptibly slow. This geological conveyor belt has been operating since before Columbus reached America, a reminder that landscapes can flow like very slow rivers. The Boogaboo Spires in British Columbia thrust granite towers 3,000 feet straight up from surrounding glaciers, creating one of the most dramatic mountain landscapes in North America. These spires are part of the Boogaboo Batholith, formed from magma that cooled slowly underground about 100 million years ago. Glacial erosion has carved away the softer surrounding rock, leaving these resistant granite towers standing like monuments. The contrast between the white glaciers and the gray granite creates a landscape of stark beauty. The spires have names that reflect their appearance: Hauser Tower, Pigeon Spire, Snowpatch Spire, each one a technical climbing challenge that attracts mountaineers from around the world. The granite here is exceptionally solid, with crack systems that run for hundreds of feet, making it ideal for traditional climbing. Between the spires, glaciers flow in slow motion, their surfaces crevassed and serrated. The area experiences its own microclimate, with storms building quickly around the towers. In winter, the spires become plastered with rime ice, creating fantastical formations that last until spring winds strip them away. New Mexico's Brazos Cliffs reveal 250 million years of geological history in exposed rock layers 2,000 feet high, a vertical library of Earth's story. These cliffs in the Tusis Mountains display layers from the Pennsylvanian through the Jurassic periods, each band of rock representing different environments: ancient seas, sand dunes, river deltas, and lake beds. The cliff face changes color with each layer: red sandstones, white limestone, gray shale, and yellow siltstone, creating a striped pattern visible for miles. Fossils are abundant in certain layers, including marine invertebrates from when this area was covered by shallow seas. The cliffs formed when the Rio Grande Rift pulled apart, creating faults that lifted these rocks into vertical exposure. Erosion has carved amphitheaters and slot canyons into the cliffs, each revealing different chapters of geological time. From the base of the cliffs, looking up through 250 million years of history compressed into a single view, creates a vertigo, not of height, but of time. These rocks were already ancient when the Rocky Mountains began to form. The Bow Valley in Alberta functions as a massive wind tunnel, channeling air through the narrow mountain gap at speeds that can exceed 100 miles per hour. This valley, carved by glaciers and now occupied by the Bow River, creates a venturi effect where winds accelerate as they squeeze through the constriction. The town of Canmore sits in this wind tunnel, experiencing Chinook winds that can raise temperatures by 40 degrees in a matter of hours. These warm, dry winds descend from the mountains, compressed and heated as they fall, sometimes melting a foot of snow in a single day. Trees in the valley grow bent and flagged, shaped by the constant wind into living weather vanes. The wind has influenced everything from wildlife behavior to human settlement patterns. Eagles and hawks use the powerful updrafts along the valley walls for soaring, while ground-dwelling animals seek shelter in protected microclimates. The indigenous peoples who first lived here built their winter camps in spots sheltered from the wind, knowledge passed down through generations about where the valley offers refuge from its own weather. Idaho's Sawtooth Mountains compress 57 peaks over 10,000 feet into an area of just 678 square miles, creating one of the most densely packed collections of alpine summits in North America. These mountains earned their name from their jagged profile, resembling the teeth of a giant saw blade against the sky. The range is predominantly granite, part of the Idaho batholith, one of the largest granite formations in North America. The granite here intruded about 80 million years ago and has been sculpted by ice and water into sharp arêtes, narrow ridges, and near-vertical faces. Over 300 alpine lakes fill basins carved by glaciers, many so remote they have no names. The sawtooths create their own weather, with summer afternoon thunderstorms building over the peaks with clockwork regularity. Lightning strikes are so frequent that many of the highest summits show evidence of repeated strikes. Shattered rock and fused minerals where electricity has passed through. The range forms a barrier between the humid forests of central Idaho and the high desert to the south, creating dramatically different ecosystems on opposite sides. The Morrison Formation stretches across 8 states in the American West, containing more Jurassic dinosaur fossils than anywhere else on Earth. This rock unit, laid down between 156 and 145 million years ago, represents a time when the Rocky Mountains didn't exist, and this region was a vast, flat floodplain. The formation has produced fossils of over 70 dinosaur species, including the first discoveries of Stegosaurus, Allosaurus, and Apatosaurus. The different colored layers, green, gray, red, and purple, indicate changing environmental conditions as rivers meandered across the ancient landscape. Some layers contain not just bones but skin impressions, gastroliths, stomach stones, and even dinosaur footprints preserved in ancient mud. The Morrison Formation extends from New Mexico to Montana, underlying much of the Rocky Mountain region. Where erosion has exposed it, particularly in Colorado and Utah, it creates badlands of banded colors. Each new discovery in the Morrison adds details to our understanding of the Jurassic period, a time when giants walked where mountains now stand. The Continental Divide Trail runs 3,100 miles along the Rocky Mountain spine from Mexico to Canada, following the height of land that separates Atlantic and Pacific watersheds. This trail, less developed and more challenging than its cousins the Appalachian and Pacific Crest Trails, traverses some of the most remote and spectacular terrain in North America. Hikers on the trail cross the divide hundreds of times, zigzagging back and forth across the invisible line that determines the fate of raindrops. The trail passes through environments ranging from desert to alpine tundra, climbing over mountain passes above 14,000 feet and descending into valleys where grizzly bears still roam. In Colorado alone, the trail stays above 10,000 feet for hundreds of miles. Weather on the divide can be extreme. Lightning strikes are a constant summer danger, and snow can fall any day of the year. The trail isn't always a trail. In many places, it's merely a concept, requiring navigation skills to follow. Those who complete the entire trail, a journey that takes 4 to 6 months, have traced the backbone of a continent. The Athabasca River begins its 1,200-kilometer journey from the Columbia ice field, flowing northward in defiance of the common assumption that rivers flow south. Born from glacial meltwater at the highest point of its watershed, the river carries the pulverized rock flour that gives it a distinctive milky turquoise color. This glacial flour, ground finer than talcum powder by the immense weight of moving ice, remains suspended in the water for hundreds of miles. The river descends through multiple life zones, from barren glacial moraines through alpine meadows into montane forests, and eventually to the boreal wilderness. Along its course, the Athabasca carves through some of the Canadian Rockies' most spectacular valleys, including the Valley of the Five Lakes, where underground springs create pools of impossible blues and greens. The river's northward journey seems like a rebellion against expectation, flowing toward the Arctic rather than seeking warmer seas. Eventually, the Athabasca reaches Lake Athabasca and contributes to the Mackenzie River system, its waters destined for the Arctic Ocean after traveling through some of North America's most remote wilderness. Fremont Lake in Wyoming plunges 600 feet deep into the earth, making it the state's second deepest natural lake. This glacially carved basin holds water so pure and cold that it remains nearly sterile at depth, too cold and nutrient poor to support much life. The lake stretches for 9 miles along the base of the Wind River Range, its depths hiding features that would be considered mountains if the water were drained away. The lake formed when massive glaciers carved a valley, then retreated, leaving natural dams of glacial debris. The water maintains near freezing temperatures year-round at depth, preserving anything that sinks into a state of suspended animation. Native lake trout grow slowly in these cold waters, some reaching ages exceeding 50 years. The lake's clarity allows visibility to depths of 30 feet or more, revealing an underwater landscape of submerged cliffs and boulder fields. In winter, the lake freezes with ice thick enough to support vehicles, but strange booming sounds echo across the frozen surface as the ice expands and contracts, earning local names like Lake Thunder for these mysterious noises. The Castle Mountain Thrust Fault in Alberta pushed rock formations 30 kilometers northeast over 75 million years, stacking ancient limestone on top of much younger shale in a display of tectonic power. This thrust fault created Castle Mountain itself, a massive castellated wall of limestone that rises above the Bow Valley like a fortress built by giants. The mountain's distinctive profile comes from the alternating layers of hard limestone and softer shale, creating a stepped appearance resembling castle battlements. The thrust fault represents just one segment of a much larger system that built the Canadian Rockies, where the Earth's crust shortened by over 200 kilometers as tectonic plates collided. Walking along the fault trace, you can place your hand on the exact surface where millions of years of geological time have been scrambled, where rocks that should be buried miles deep sit exposed to mountain air. The fault remains visible as a distinct line across the mountain face, a geological scar that tells of unimaginable forces acting over incomprehensible time. Fossils from tropical seas appear in the thrust sheets, creatures that lived and died when this location was at sea level and much farther south. Mirror Lake in Utah sits at 10,200 feet elevation in the Uinta Mountains, remaining frozen 7 months of the year beneath ice that can reach 6 feet thick. The lake earned its name from its perfect reflections during the brief summer months when the ice melts and the wind stills. Surrounded by peaks that rise directly from the water's edge, the lake creates double mountains in its surface, reality and reflection becoming indistinguishable. The lake occupies a basin carved by glaciers that retreated just 10,000 years ago, leaving polished rock surfaces that still show scratches from stones embedded in the moving ice. At this elevation, the growing season lasts barely 60 days, yet wildflowers explode in the meadows surrounding the lake, compressed life cycles playing out in fast motion. The lake supports a population of brook trout introduced decades ago that have adapted to the extreme conditions, growing slowly and living longer than their low-elevation cousins. Winter arrives in September and doesn't release its grip until June, creating an environment more Arctic than temperate, despite being at the same latitude as Denver. The Selkirk Mountains in British Columbia receive over 50 feet of snow annually in some locations, creating one of the deepest snowpacks on Earth outside of polar regions. This incredible accumulation results from their position as the first major barrier to Pacific storms moving inland. The mountains wring moisture from these systems with remarkable efficiency, with some valleys recording over 2,000 inches of snowfall in exceptional years. The weight of this snow creates glaciers at relatively low elevations, and the Selkirks contain over 300 glaciers, despite being farther south than many glacier-free ranges. Ancient forests of giant cedars and hemlocks thrive in the valleys, sustained by the constant moisture from melting snow. These inland rainforests contain trees over 1,000 years old and 15 feet in diameter, rivaling the coastal rainforests in size and age. The deep snow creates unique challenges and opportunities. Caribou have evolved specialized hooves that act like snowshoes, while skiing here requires understanding of complex avalanche conditions. The mountain's name comes from Scottish settler Lord Selkirk, but indigenous peoples knew them as the Mountains of the Winter Spirit, acknowledging their snowbound character. Pikes Peak inspired Catherine Lee Bates to write America the Beautiful. When she reached its summit in 1893, the view encompassing Purple Mountain's majesty and amber waves of grain stretching to the horizon. Rising 8,000 feet above Colorado Springs, the mountain dominates the southern Colorado landscape, visible from over 100 miles away on clear days. The peak formed from a billion-year-old granite batholith, the same pink granite that creates the Garden of the Gods formations at its base. Unlike many Colorado 14ers that require technical climbing, Pikes Peak has a road to its summit, along with a cog railway that has carried visitors since 1891. The summit experiences extreme weather, with winds exceeding 100 miles per hour and temperatures that can plunge to 40 below zero even in summer. Despite these conditions, a small herd of Rocky Mountain bighorn sheep lives year-round near the summit, subsisting on alpine plants that grow in the brief summer. The mountain served as a beacon for travelers on the Great Plains, a landmark that meant the end of prairie travel and the beginning of mountain challenges. The Kicking Horse River in British Columbia drops 1,260 meters in just 85 kilometers, creating one of the steepest river gradients in the Canadian Rockies. The river earned its name when James Hector, a member of the Palliser expedition, was kicked by his horse near the river in 1858. The river's steep descent created major challenges for the Canadian Pacific Railway, requiring elaborate spiral tunnels to reduce the grade to manageable levels. In these tunnels, trains travel in complete circles inside the mountains, emerging higher, but having traveled miles in darkness. The river has carved a spectacular canyon, with walls so steep that the Trans-Canada Highway requires bridges and tunnels to navigate the gorge. The turquoise water, colored by glacial flour from the Waputehk icefield, contrasts dramatically with the dark canyon walls. Whitewater rafting here ranks among the most challenging in North America, with rapids that can flip rafts and send paddlers into water barely above freezing. The river's power has been partially harnessed for hydroelectricity, but much of its course remains wild, a thundering reminder of water's ability to carve through mountains. Granite Peak in Montana stands at 12,807 feet as the state's highest point, but also as one of the most challenging state high points to reach in the contiguous United States. The approach alone requires a 20-mile round-trip hike with over 7,000 feet of elevation gain, and the final ascent involves exposed scrambling on loose rock with 1,000-foot drops. The peak sits in the Absaroka Beartooth Wilderness, surrounded by glaciers and permanent snowfields. The granite here formed deep underground and was exposed by millions of years of erosion, creating a landscape of sharp ridges and narrow couloirs. Weather on Granite Peak can change from calm to deadly in minutes, with afternoon thunderstorms arriving with little warning. The summit plateau is smaller than a living room, with drop-offs on all sides that have claimed several lives. From the top, the view encompasses much of the greater Yellowstone ecosystem, with mountain ranges extending to every horizon. The peak remained unclimbed until 1923, one of the last major summits in the lower 48 to be ascended, testament to its remoteness and difficulty. The Wasatch Range in Utah rises 7,000 feet above Salt Lake Valley in less than 5 miles horizontal distance, creating one of the most dramatic mountain fronts in North America. This abrupt rise results from the Wasatch Fault, an active fault system that continues to lift the mountains while dropping the valley. The fault has created a situation where you can travel from desert salt flats to alpine tundra faster than anywhere else on the continent. This extreme relief creates multiple climate zones stacked vertically. Desert scrub at the base, oak and maple forests on lower slopes, aspen groves at middle elevations, conifer forests higher up, and alpine tundra on the peaks. The mountains trap winter storms moving in from the Pacific, creating legendary powder snow conditions that fall as lake-effect snow when cold air moves over the Great Salt Lake. 7 major canyons cut through the range, each one a gateway from urban valleys to wilderness in minutes. The Wasatch Fault remains active, with earthquakes expected that could dramatically change the landscape in seconds, adding feet to the mountain's height while dropping the valleys further. Wyoming's Red Desert encompasses 9,300 square miles of the largest unfenced area in the continental United States, a vast expanse where antelope still migrate along routes used for thousands of years. This high-altitude desert sits at over 6,000 feet, making it one of the highest deserts in North America. Despite its name, the desert displays a palette of colors: white alkali flats, black volcanic buttes, yellow sandstone cliffs, and yes, red sediments that give it its name. The desert receives less than 10 inches of precipitation annually, yet it supports a remarkable diversity of life adapted to extreme conditions. Wild horses roam here, descendants of Spanish colonial horses, along with the largest migratory herd of pronghorn in the lower 48. The desert contains the Continental Divide Basin, a unique geographical feature where water doesn't flow to any ocean, but evaporates or seeps into the ground. Fossil sand dunes, now stabilized by sparse vegetation, tell of a time when this was an even drier, shifting sand sea. The isolation and harsh conditions have preserved archaeological sites dating back 10,000 years. The Fraser Canyon narrows to just 35 meters at Hell's Gate, while carrying the full flow of Canada's third largest river, creating a hydraulic spectacle of tremendous power. Here, the Fraser River, draining over 230,000 square kilometers of British Columbia, forces itself through a gap barely wider than a residential street. The water velocity reaches 35 kilometers per hour, creating standing waves, whirlpools, and hydraulic features that would destroy any vessel attempting passage. The constriction exists because the river cuts through the coast mountains, maintaining an ancient course as the mountains rose around it. Indigenous peoples developed ingenious fishing platforms suspended over the torrent, harvesting salmon that gathered in eddies beside the main flow. The construction of railways through the canyon in the early 1900s triggered rock slides that further constricted the channel, nearly destroying the river's salmon runs, until fish ladders were built. The roar of water through Hell's Gate can be heard for miles, a constant thunder that vibrates through the canyon walls. In spring flood, the river level can rise 15 meters, turning the entire canyon into a hydraulic chaos. Royal Gorge in Colorado spans 1,250 feet across, while plunging 956 feet to the Arkansas River below, creating a chasm so deep and narrow, it seems impossible that a river carved it. The gorge formed over the last 3 million years as the Arkansas River cut downward while the surrounding landscape lifted. The granite walls are so hard that the river could only carve straight down, creating this slot canyon on a gigantic scale. The Royal Gorge Bridge, built in 1929, held the title of world's highest bridge for decades. Standing on the bridge, you can feel it sway in the wind while the river below looks like a silver thread. The gorge creates its own microclimate, temperatures at river level often 20 degrees different from the rim. Peregrine falcons nest on the cliff faces, using the 1,000-foot drops as protection from predators. The narrowness of the gorge meant that early railroads had to hang their tracks from the canyon walls, an engineering feat that required workers to be lowered on ropes to drill and blast. The Arkansas River continues to deepen the gorge, though at a rate measurable only in geological time. The belt sea that covered Montana 1.4 billion years ago left sediments 18,000 feet thick in places, preserving a record of Earth's middle age when complex life had not yet evolved. These belt supergroup rocks, exposed throughout western Montana and northern Idaho, contain structures that look like elephant skin, mud cracks, and ripple marks from that ancient sea. The sea existed for over 100 million years, accumulating sediments grain by grain in shallow, warm waters. These rocks contain some of Earth's oldest evidence of photosynthetic life, stromatolites that represent vast colonies of cyanobacteria that helped oxygenate Earth's atmosphere. The belt rocks display subtle colors, pale greens, purples, and reds, from trace minerals deposited in different conditions. When you touch these rocks, you're touching sediments that settled when Earth's day was only 18 hours long. The moon was closer, and the continents were arranged in configurations we can barely imagine. Glacier National Park's colorful peaks are carved from belt rocks, their banded appearance telling the story of this ancient sea in layers visible from miles away. Mount Temple in Alberta rises to 11,627 feet, its massive bulk visible from 80 kilometers away on clear days. The mountain presents a north face that rises 1,800 meters from Moraine Lake, one of the highest cliff faces in the Canadian Rockies. Temple is built from layer upon layer of limestone and shale, sediments from ancient seas stacked like a giant layer cake. These distinct bands create ledges and cliffs that circle the mountain at consistent elevations. The mountain acts as a weather maker, its bulk forcing air masses upward and creating clouds that often shroud the summit while surrounding peaks remain clear. Avalanches thunder down Temple's faces with regularity, some large enough to cross the valley floor and run up the opposite side. The mountain's east ridge provides a non-technical climbing route, but the elevation gain of 1,700 meters makes it one of the most physically demanding scrambles in the Rockies. From Temple's summit, you can see much of the Continental Divide, a sea of peaks extending to every horizon. The Lemhi Range in Idaho extends 90 miles but spans only 15 miles at its widest point, creating a narrow wall of mountains between valleys. This linear range formed along a fault system that continues to be active, occasionally producing earthquakes that remind us these mountains are still growing. The range contains Mount Bora, Idaho's highest peak, and 8 other summits exceeding 12,000 feet. The narrow configuration creates dramatically different conditions on opposite sides. The west side receives Pacific moisture, while the east side sits in rain shadow, supporting near-desert conditions. The range provides critical habitat for mountain goats, bighorn sheep, and one of Idaho's largest elk populations. The crest of the range follows a knife-edge ridge in many places, with 1,000-foot drops on both sides. Archaeological evidence shows humans have crossed these mountains for over 10,000 years, using the same passes that modern highways now follow. The limestone and quartzite peaks have been carved by glaciers into sharp horns and serrated ridges, creating a skyline that looks like a saw blade from the valleys below. Yellowstone Lake sits at 7,732 feet elevation, freezing with ice 3 feet thick despite hot springs bubbling from its bottom. A surreal combination of ice and fire. The lake covers 136 square miles, making it the largest high-elevation lake in North America. Beneath its waters, hydrothermal vents discharge water hot enough to cook food, while the surface freezes solid enough to support vehicles in winter. The lake occupies part of the Yellowstone caldera, and its bottom reveals underwater hot springs, fumaroles, and even geyser-like features. Sonar mapping has revealed explosion craters on the lake floor, some several hundred feet across, created by hydrothermal explosions. The lake's strange duality extends to its ecology. Cutthroat trout thrive in the cold surface waters, while thermophilic bacteria cluster around hot vents on the bottom. In spring, the ice breaks up in dramatic fashion, with house-sized chunks grinding against each other in the wind. The lake can generate waves over 6 feet high, despite being surrounded by mountains, conditions that have claimed many boats over the years. The Purcell Trench forms a valley 2,000 feet deep and 3 miles wide that runs for 200 miles through British Columbia and Montana, so straight it looks artificial from space. This remarkable valley formed along an ancient fault zone, creating a natural highway that rivers, wildlife, and humans have used for millennia. The trench is so prominent that it's easily visible from orbit without magnification, a great gash across the landscape. The valley floor contains a string of lakes, including part of Koocanusa Reservoir, that fill the deepest parts of the trench. The consistent depth and width along its entire length suggest formation by a single geological process, though the exact mechanism remains debated. The trench separates the Purcell Mountains from the Rocky Mountains proper, creating a biogeographical barrier that influences species distribution. Rivers entering the trench from side valleys often make 90-degree turns to follow the trench rather than crossing it, demonstrating its controlling influence on drainage patterns. The valley channels weather systems, creating a corridor for Pacific air masses to penetrate inland. Colorado's Homestake Mine operated from 1880 to 1987, removing an entire mountain and creating a valley where a peak once stood, one of the most dramatic human modifications of the Rocky Mountain landscape. The mine extracted over 28 million ounces of gold and silver, processing entire mountains into rubble to extract precious metals. What was once a prominent peak is now a bowl-shaped pit, with terraced walls descending to a toxic lake at the bottom. The scale of removal is difficult to comprehend. Roughly 200 million tons of rock were moved, processed, and discarded. The tailings from the mine stretch for miles down the valley, creating new landforms that will persist for geological time periods. Despite environmental damage, nature is slowly reclaiming the area, with pioneering plants beginning to colonize the waste rock. The mine's legacy includes not just the missing mountain, but altered drainage patterns, heavy metal contamination, and a completely reorganized landscape. From nearby peaks, you can see the ghost of the original mountain in the surrounding topography. Imagination filling in what industry removed. The Columbia River begins in the Rocky Mountain Trench of British Columbia, starting a 2,000-kilometer journey that will take it through deserts, over waterfalls, and finally to the Pacific Ocean. The river's source, Columbia Lake, sits at an elevation of 820 meters, remarkably low for such a major river's beginning. From here, the Columbia flows northwest for 300 kilometers before making a sharp turn south, a course known as the Big Bend. This seemingly wrong-way flow results from the river following the Rocky Mountain Trench before finding a way through the Columbia Mountains. The river predates most of the mountains it flows through, maintaining its course as the landscape rose around it. Along its journey, the Columbia cuts through multiple mountain ranges, creating spectacular gorges and supporting the largest hydroelectric system in North America. The river carries sediment from the Canadian Rockies all the way to the Pacific, building underwater fans that extend miles into the ocean. Its watershed encompasses parts of 7 states and one province, draining an area larger than France. Utah's Notch Peak features a 2,200-foot limestone cliff face, one of North America's highest pure vertical drops. This massive wall of Cambrian limestone rises from the desert floor like a geological tsunami frozen in stone. The cliff formed along a thrust fault where older rocks were pushed up and over younger formations. Then erosion carved away the softer rocks, leaving this spectacular precipice. The limestone here formed 500 million years ago in tropical seas, and fossils of trilobites and other ancient marine life can be found throughout the formation. From the base of the cliff, the wall appears to lean outward, an optical illusion created by its sheer scale. Rock climbers consider the face one of North America's great challenges, with routes requiring multiple days on the wall. The summit, accessible via a hiking route from the backside, offers views extending to Great Basin peaks over 100 miles away. The cliff creates powerful updrafts that golden eagles use for soaring, sometimes rising thousands of feet without a single wing beat. Standing at the base and looking up induces a particular kind of vertigo, where the solid earth itself seems to be falling upward into the sky. As we reach the end of our journey through the Rocky Mountains tonight, we've traced the spine of a continent through stone and time. These mountains stand as Earth's library, their layers recording stories of ancient seas, volcanic fury, and the patient work of ice and water. From the tropical swamps that once covered Wyoming to the glaciers that still cling to Alberta's peaks, from microscopic fossils in billion-year-old rock to valleys carved yesterday by falling stones, the Rockies reveal how landscapes live and breathe across incomprehensible spans of time. Tomorrow, these peaks will be imperceptibly different. A grain of sand moved by wind, a drop of water freezing in a crack, another millimeter of growth along an active fault. But tonight, they stand eternal in our imagination, a chain of stone dreams stretching from desert to Arctic, dividing waters and joining skies. The Rockies remind us that Earth itself is alive, constantly reshaping itself through processes both violent and gentle. Mountains rise and fall, seas advance and retreat, and through it all, life finds ways to persist in the most improbable places, in hot springs and frozen lakes, on vertical cliffs, and in valleys deeper than clouds. Thank you for joining me on this journey through North America's backbone. May your dreams tonight carry you to high places where the air is thin and clear, and the world spreads out below like a map of possibility. May you find yourself standing on ancient seafloors, lifted to touch the sky, or beside lakes that mirror eternity, or in valleys where rivers older than mountains still flow toward distant seas. Until we meet again in the gentle hours of night, sleep well and pleasant dreams.